Okay guys, today we're going to be talking about solving systems of equations, and we're going to be solving systems of equations using the method of substitution. So solving systems by substitution, what does that mean? So these are the following steps that you would need in order to solve systems of equations by substitution. So a system basically means more than one equation, so they're going to give you probably two equations at once and you have to solve for both. Steps. Solve for one of the equations for the variable, doesn't matter which one. You got to get one variable by itself on one side for one of the equations. Step 2. You have to substitute the expression of the variable into the other equation once you solve it using the method of substitution, hence the term, by substitution. And then step 3, solve for the equation now that you have one variable in one equation. So once you plug it into the other equation, you can actually solve it. Finally, you want to plug it into one of the original equations, any original equation, doesn't matter which one, to solve for the other variable that you don't have. And then the last step is just check your work. So make sure you check your answers. Sometimes you get two answers and then you got to make sure they make sense, because if they don't make sense with the original equations, then you know you did it wrong. You can go back and then check your work. So especially when it comes to testing or a test, you can go back and check your work and make sure that you got it 100% correct. Okay, so let's work through these examples. So I got a couple of examples ready for you guys. So example number 1, let's do this one first. So we have to solve this by substitution. We have to make sure that one of the variables is alone on one side for one of the equations. Now, if I look at this equation, for the first one, that one doesn't have any variables alone on one side. But if I look at the second one, that one does. So y is actually alone on one side, all by itself. So this tells me that y is equal to 3 plus x. So now what I'm going to do is, on the other equation, I'm going to substitute that expression for y, because this means the same as that, right? So y is equal to 3 plus x. So instead of writing y on the other equation, I'm going to write 3 plus x. So let's try to use that to be able to solve the equation for one of my variables. So I'm going to rewrite this the way that I see it, right? So x plus y is equal to 5. But instead of writing y, I'm going to substitute the equation for y, which is 3 plus x. So now I get x plus 3 plus x is equal to 5. Okay, so I got the variable on one side, substitute into the other equation, and I plug it in, and this is what I got. So let's simplify. There's nothing in front of the in front of the parentheses, so it means that I don't have to distribute or multiply by anything. So pretend like it's not there. This is basically telling me x plus 3 plus x is equal to 5. Combine like terms. If you do that, that means that x plus x is just 2x. 2x's, right? So 2x plus 3 equals 5. Draw the wall and solve for x. Subtract 3 on both sides. You're probably used to this by now, so it'll be easier. 5 minus 3 is equal to 2. Divide by 2 on both sides. So 2 divided by 2 is 1. So therefore the answer for x equals 1. Great, I have the answer. Am I done? No, you are not done. The answer is not 1. It wants you to solve for both x and y. So now that I have that answer, I have to plug this value of x into one of the original equations, whichever one you want, to be able to solve for y. Now one of them will be better, right? This one already has a y by itself on one side, so let's just plug it into that. So if x is 1 and y is 3 plus x, then therefore y has to be 3 plus 1, which means that it's equal to 4. So my final answer would be x equals 1, y equals 4. That would be your final answer. You can also write this as a point. Sometimes they write it as 1 for x, 4 for y, or 1 comma 4. And make sure you check your work. So the last step that I wrote down on there is for you to check your work. So I'm going to go ahead and check my work on a separate piece of paper. So I'm just going to do it on this back right here. So let's see if it actually makes sense. My two equations in the beginning were x plus y equals 5. And the other one was y equals 3 plus x. Now I got my answers. My answer for x and my answer for y, right? X was equal to 1. So let's plug in 1 for x and then 4 for y. So 1 plus 4 equals 5. We have to check to make sure that makes sense. And then let's plug in 4 for y, and then 1 for x. So 4 is equal to 3 plus 1. Does this make sense? The top equation, if you notice, it's 4 plus 1, which is 5, so we get 5 equals 5. That makes perfect sense, so that we know we got it right. On the bottom, 4 is equal to 3 plus 1. Yep, 4 is equal to 4, so that does make sense, so we know we got it 100% correct, so we're happy. Okay, so even though you got the answer, you can go back and check your work, plug it back into the original two equations. You get something that's true, then it means you got it correct. So just check your work, just to be safe. Example number 2. So for example number 2, we have this problem. We have 3x minus y is equal to 4, and then x is equal to 4y minus 17. Now, we have to make sure we get one of the variables by itself on one time, which we already kind of do, right? We have the x by itself on one side. So we can use this expression for x and plug it into the other equation where the x belongs. So I'm going to take that value of x, or that expression, for x minus 17. I'm going to plug it into the spot where the x should be in the other equation. So we only have one single equation. So I'm going to rewrite the top one, 3x, but instead of x, I'm going to write parentheses, minus y is equal to 4. And instead of x, where that parentheses was, I'm going to plug in the expression for x that they give me, which is 4y minus 17. So I have 3x, right, minus y is equal to 4. Now we can solve it. So this time we do have to do some distribution because we have a number outside of the parentheses. So we have to do the distributive property, multiply everything by 3. 4 times 3 is 12, so that gives me 12y. Minus 17 times 3, what is that? 50, 30, 51? I think that's 51. And then minus y is equal to 4. Combine like terms. If you notice, that and that can be combined. 12y minus 1y is equal to 11y, so this becomes 11y from the underline section. Minus 51, so we just drop down to 51 and set that equal to 4. We do plus 51 on both sides, plus 51, plus 51. So draw the wall, add 51 to both sides. So we get 11y is equal to 51 plus 4 is 55. Okay. Finally, we divide by 11 on both sides, divide by 11, divide by 11, so we can get the y alone, and we get y is equal to 55 divided by 11, which is 5. So we get an answer, y equals 5. Are we done? No, we haven't solved for x yet, right? So we have to go back and figure out what the value of x was. So now that we have y, we can plug it into one of the original equations to figure out x. This one would be easier because the x is already by itself, so we can actually just plug in 5 for y and then try to figure out what x is. So let's do that. So x, I'm going to write it up here, is equal to 4y minus 17. But we already know y, right? So 4 times 5 minus 17, which means that it's equal to 20 minus 17, which means that it's equal to 3. So there's my answer. So my answer for x is 3 and my answer for y is 5. I can write that as a point, right? So I can write this answer as 3 for x and then 5 for y, or 3 comma 5. So sometimes they'll give you the answer as a point. Now, even though we're done, like I said in the beginning, you should check your work just to make sure that you got it right. So the two original equations that I got for the problem were this and this. So x equals 4y minus 17, and then 3x minus y equals 4. Now I want to make sure that these two are actually correct. So I'm going to plug in x equals 3 and then y equals 5. So I'm going to do that on this side. So if I do that, I get 3 parentheses 3, and then minus 5 is equal to 4. Here I'm going to get 3 is equal to 4 parentheses 5 minus 17. And then if you check to make sure that if this makes sense, 3 times 3 is equal to 9, right? So 9 minus 5 is equal to 4. The top one is actually true. It makes sense because 4 equals 4. If you check the bottom one, it's going to be 5 times 4, which is 20. 20 minus 17, would that be equal to 3? Well, yes, it would, right? 3 equals 3, so we are 1. Happy people, we got the same answer. It actually works out and we checked our work. Okay, finally, just in case you still don't get it, let's do one more example of solving systems of equations by substitution. And this time I'm going to make it hard on you guys. We are not going to be able to solve for the variable, or actually the variable is not solved for us yet, so we have to do that ourselves. So just pick a variable to solve for. I'm going to go ahead and pick the top equation. I'm going to solve the top equation for x because it looks like it's easier to do. So if I do that on the side somewhere, so I get 3y plus x is equal to 7, draw the wall, minus 3y minus 3y, so now I have my x by itself. X is equal to negative 3y plus 7. Now, now I have a variable by itself. I know that x is equal to this, which is 3y plus 7. Now I can do the same steps that I did in the other problem, right? So now that I have my x, I can substitute that x into the other equation, right? So this guy right there, where the x goes. So I'm going to write it out, 4 parentheses x, right? This is where the x would go, minus 2y is equal to 0. Instead of the x, though, I'm going to write the expression, which is negative 3y plus 7. So that's where the x belongs, but I substituted negative 3y plus 7, which is the same equivalent of x. Now we have to solve it. Again, this time we do have a number outside the parentheses, so we have to distribute, right? Distributive property. 4 times negative 3 is negative 12y. 4 times 7 is 24, so we're going to put the positive 24 there, minus 2y is equal to 0. Combine like terms, we can actually combine the negative 2y and the negative 12y to get a negative 14y plus 24 equals 0. And then we can solve this by doing inverse operations. So we do minus 24 on this side, minus 24 on this side. We get negative 14y is equal to negative 24. And then finally, divide by negative 14 on both sides. Okay, so let's see. It looks like this one is a weird answer for some reason, which probably means that I copied down the problem wrong, which means that you may not get a nice answer, but I guess the steps are okay. So all we can do here is just simplify it. So the negative and the negative cancel. So we get 24 divided by 14. The only thing we can do is just divide top and bottom by something. If I divide top and bottom by, I don't know, let's say 2. So the top I get 12, on the bottom I get 7, so 12 over 7. Now, if you want to figure out what the value of x is, you would plug this into that equation to get x. So for example, x is equal to negative 3 parentheses y, which is 12 over 7, plus 7. And then you get negative 3 times 12, which is 36. So I'm going to write negative 36 over 7 plus 7. And that becomes negative 36 over 7 plus. If I turn the 7 into the same thing, I can multiply top and bottom. Sorry, this should be a 7 over 1. If I multiply by 7 on top and on the bottom, I get 49 over 7. Which means that my final answer, this ugly fraction, ugly problem that I probably copied down wrong, should be equal to 13 over 7. So this is the value for x, right? So x is this, and then y is that. All right, so sorry about the last example, but you get the idea. So if you follow the steps, the problem shouldn't be too bad. See you guys on the next video.